Welcome all. Today we are going to see that constraint satisfaction problem. So this is one of the very important problem in AI, and we can call it as a short term for CSP. So this is one of the mathematical problem where the set of variable must satisfy given the particular constraint. So these problem work in a space of constraints, that is we can call it as a search space. It can be widely used for the AI models. And then the CSP, it can be consist of the three component, important component. We can call it as a variable, that is a set of variable, and then domain, and then finally the constraints. The set of variable we can call it as a short term for V, and then domain for each variable we can call it as a D, and then constraints we can call it as a C. So these are all the variable names. So we can assign the variable for in this order only. So now we can see the some important thing for the constraints. So the important thing for the constraints, generally we can constraints we can apply for the some of the logical and then mathematical relationship among the variable. So the constraints can be classified into the three process. So the first one, unary constraint, and then binary constraint, and then higher order constraint. Unary constraint, it means we can always assign with the single variable, and then binary constraint we can always call it as a two kind of the variable, and then higher order constraint we can call it as a three or more kind of the variable. So that's why these are all the important thing for the constraint choosing method. And then these constraints, it can be some restrict some of the value for the particular variable. So this is a very important thing for the constraints. And then these constraints we can apply for the three real-time problems. So the first one, the crypt arithmetic puzzles, and then the map coloring, and then cross-world puzzles. So these are all the important three based upon the constraints problem. We can call it as the thing. And then the example of CSP. So here we can just assignment problem for the who teaches what class. So these are all the three kind of the examples of the CSP problem. The assignment problem, we can just give the some instructions to the students. So who the teachers what class, like that. And then timetabling problem, so which class is offered when and where. So for which kind of the classes, it will be just mapped into the with the help of the CSP thing. So we can easy to find out for particular time and then particular class what kind of the class it will be happening, then relevant to the timetable mapping functions. And then transportation scheduling, so like the from state and then the end state, everything it will be covering. And then the factory scheduling, that is a time based for scheduling process. So these are all the real time example for the CSP problems. So this is one of the real world problem, like the school and colleges or any timetable based upon the work activity, it will be related to the CSP. And then the management of employee to achieve the sometime task with like the time based line function, and then from to and then end and then layer function of the process. So everything it should be covered into the some CSP based upon the constraints. And then course planning and then scheduling, and then bus route planning, for example the start position and then destination position, etc. And then resource allocation, so particular resource, so which task is going to achieve for the first level. And then the sixth one, network configuration, so which kind of the configuration we need, and then which kind like how much of the spaces it should be just utilized for the particular thing. Okay, so while using the internet, so everything it should be just based upon the CSP problem of some limited constraints. So constraints already we know, like the three important constraints based upon the variable, and then based upon the the three things of the constraints. Okay, so VDC, that representation only we can just fix it into the particular model of problems. So this is the first one, crypt arithmetic problem. This is one of the very easiest problem solving method. So this is one of the important constraints and then rules for solving our crypt arithmetic problem. So the first one, every character, that is every character in that problem, okay, so must we have to assign the some unique value. That unique value, it can be represent like the 0 to 9. So whatever the value it should be comfortable for the character, we can assign it. Okay, the third condition is starting the character of the number cannot be 0. So starting number, whenever we can assign with the starting character of the number, we cannot able to assign the 0. So this is the third constraint, that is a condition. And then crypt arithmetic problem will have only one solution. So finally we will get the solution as a only one solution with the proper model. And then the addition of the number with itself, the always the even. So whenever we need the addition of the thing, always it should be the even. In case the addition of two number, it just carry over means it will be just to do for the next step of process only. Okay, so this is the thing. So this is the thing for we can make with the crypt arithmetic problem of rules and conditions. So this is the sample problem. So the first our constraints is what now, we have to assign the characters. Okay, so this is the character they have given. So these are all the thing, we can call it as a character or letters like that. Okay, or variables like that. And then the domains means what now, 0 to 9. Okay, 0 to 9 as a domain of the variables here. Okay, so these upon the variables we have to variables and then values we have to assign with this inside the problem. Okay, so first what the thing we should do now, so first one we can take with the character like T O G O, and then finally we will get O U T. So based upon the character we have to hiding the some domains of numbers. Okay, this is the thing. So each letter should have the unique value. Okay, each letter means each letter of the statement having the unique numbers or unique domains. There should be only the one carry forward. Finally we will get the carry as a only one. Okay, so we cannot just over come for this problem. Okay, we will get the only one carry forward for this model. Okay, so first what the thing we should do, first we have to assign the value. Okay, so 0 to 9, based upon the 0 to 9, so which number it should be comfortable for here. Okay, so that first we have to assign for the only one here. Okay, because always we have the rule is what now, we need to get the some carry forward. Okay, so that's why we have to give, or we have to just store the value for one in this place one. So we have stored the value for 1. Okay, after that we have to just which value is comfortable for this. For example, now I am going to choose T as a 2. Okay, and then G as a 8. So total we are having the 10. So 10 now 0, the remainder is 1. Okay, so I will get the carry over here, carry forward over here. And then the next one, we are having the same letter O. So which is not come for the some carry forward, that the thing we want to choose it. Okay, so that's why we have to choose like the minimum of the number here. Okay, because we want to we can choose the highest value means we will get the carry forward over here. Okay, so that the thing we should avoid it. Okay, so that's why we can take like that. So minimum of the number for this character. Okay, so 1 1 2 2. Okay, so whatever the value we can comfortable for not getting the remainder, so we will choose it here. So I am going to choose 1 1 the 2. So finally I will get like the 102 as the final number for that particular corresponding the character. Okay, so here the condition was satisfied. First one, the what is the condition, assign the letter from 0 to 9. 0 to 9 any numbers I have to assign like the whatever the present in the letters. That is the first constraint. The second constraint is each letter should have the unique number. Yes, I have chosen the unique number only. And then the third one, there should be only one carry forward. Yes, I got only one carry forward in the last moment. Okay, so this is the first example. The second example is what now? Send more and then money. Okay, so this is the second example over here. So the condition is I have to maintain the only one carry forward over here. So based upon the thing, I am going to choose like that. So here what is the number? So first I have to fix the 1. Based upon the carry forward, I have to select the numbers for here. So I have to select like what now? Maximum number, it should be present like the 0 to 9. Okay, so here yes, I have to just fix like the 9 and then 1 as the m. Okay, so finally I will get like 0 and then 1. So here I have to just assign the table like what now, I have to store the value like what now, s means 9 and then m means 1. So maybe if the S or M, it will be repeating the second moment or say third moment, means I have to use same number only. That is the condition. Okay, because only one, whenever I am getting the one character, it should be just assigned some one value, means so same value only repeated for repeat for the whenever the repeated character it will be occur. Okay, that is the condition. So S and then M, here the S and M is not here. Okay, so that's why there is no problem. I have assigned the biggest number. Okay, next one E and then O. So here E is there, here also E is there. So I have to take the number what is that correctly, and then I have to just seriously I have to focus it here. Okay, so now here I have to assign E as a 5 and then O as a 0. Okay, here 6, but I don't want the remainder here. Okay, that's why I have to maintain the like what now 5. Now I 5, but whenever I go for the next step, if I am getting the remainder, means I will add it here. Okay, so first E I have placed 5, so the same value I have to just maintain for the this position also 5. Okay, the next one, next row, N and R is that is a new character. So what are all the like the remainder of whatever the value I have chosen, so that the value I don't want to repeat. Okay, so what are all the values I am not choosing, so that value only I have to repeat that. Okay, I have to take that. Okay, so here the N and R, so the next value is what now I want to pick the N as a 6 and then R as a 8. Okay, wow. So this is the thing. So now we have to just add like the 15. Okay, so 15 now 5 and then remainder I will get the remainder 1. So totally 6. So I don't want the just remainder for the next step. Okay, only I have to store the value. Here there is no problem. Okay, so 6 and 8 and N and R, it should be repeat here. No, only E only I am having the 5. Okay, no issues. So now I want to just pick the another new value here. What are all the value I didn't choose in the previous thing. So based upon the value only I have to take. So the 7 as a new value here, but here I am getting the like 2 as the 12 as the value, so that I have to just choose like the 1. Okay, so 1 and then getting the remainder. So based upon the thing only. So now I just recalculate it. 7 plus just 5, so 12 and then 1 and then 1, it will be taking like the 7 and then 15. So in the previous we are getting the 14 only, but here we will get the remainder 1. That's why. So 15 plus 1 and then 5 plus 1 as a 6 and then 9 plus 1 as a 10 and then I will get the remainder. So based upon the thing only we are going to arranging the number into the character. But what now the main serious thing is what now, whatever the value once we have selected, so that say that the value we don't want repeated, but we are having the same letter, means we can able to repeat. Okay, that is the condition.